As San Antonio's newest hotel, the Hilton Palacio del Rio, reached for its 21st floor late in December 1967. It had already broken a dozen building traditions and construction records. Each of the 496 rooms was precast as a unit in a yard 7 miles away and trucked to the site completely finished, glazed, papered, painted, carpeted, and furnished, ready for the maids to make the beds. And to complete the structure in less than 9 months for the opening of San Antonio's World's Fair, Hemisphere 68, the 35-ton precast rooms literally flew on their way to the top. The structure was designed by architects Cerna and Garza to conform to the unique construction system developed by the owner and builder, the H.B. Zachary Company, general contractors. The hotel will be operated by the Hilton organization. The choice but limited location, a narrow, unsymmetrical strip bounded by San Antonio River, 2 streets, and an existing building, demanded a method of construction in which major fabrication could be carried on away from the site. Major on-site construction, which started on July 3rd, 1967, included a central core 73.5 by 22.5 feet. The 10-inch thick reinforced concrete walls of this towering structure were slip-formed to their full height. They enclosed elevators, closets, and central fire stairs. The end walls, containing stairwells, were slip-formed just in advance of the location of precast room units on each of the 16 guest floors. The first 4 stories, constructed of conventional flat plate reinforced concrete, accommodate the lobby, shops, offices, meeting and dining rooms, and restaurants. They form the base for the vertical stacks of 496 room units. Casting of the rectangular rooms was done in a 17-acre yard where the entire ground area was stabilized with cement to permit heavy equipment movements in all weather. 2 rows of casting beds with embedded rails for operation of jumbo gantry cranes. Each contained 8 stationary steel exterior forms. These forms were arranged in pairs with open ends facing each other. They were spaced to permit movable interior forms to be used with each pair. 8 of the forms were for 32 feet 8 inches by 13 feet room units. The other 8 were 3 feet shorter. The cycle starts with the location of plumbing waste lines and the reinforcement for 8 different floor units. Concrete is cast and finished with power floats and trowels. Each day, wall reinforcing bars are located and tied, and sections of steel cable inserted in wall areas to provide 4-point lifting loops. This is followed by location of a door frame at the closed end, service conduits and knockout plugs for air conditioning and other services. Assembly and tying of reinforcing steel for ceilings complete exterior formwork. Interior steel forms rotate 180 degrees between opposing forms. They are moved in and out of the exterior forms on retractable wheels. After the interior form is inserted, the rolling wheels are lifted and interior bracing aligns the form for the casting of 5-inch thick concrete walls. Structural lightweight concrete was delivered to the mobile crane by ready-mix trucks. The walls are cast first and consolidated both by vibrators attached to the forms and by spud vibrators operated by hand. The 4-inch ceiling slab is then placed, vibrated by hand, and rapidly finished by floating. After casting, the open end and ceiling are covered with a large sheet of canvas. After allowing an initial set of 3 hours, steam ducts are opened into the form and steam curing is begun for a 9-hour period. After the 12-hour curing cycle, and a 3,000 pound per square inch strength has been obtained, the canvas is removed. Concrete is stripped by jacking in the inside form and jacking out the exterior form. The interior form is removed, and each room unit is lifted by gantry and loaded onto a truck trailer. Thus ends one phase of a 48-hour cycle during which all 16 exterior forms are used to cast and cure 8 floors and 8 room units every 24 hours. In the finishing yard adjacent to the casting area, precast box room units are lined up in opposing rows, very much as they will be in the finished building. The 2-foot overhangs with extended reinforcing bars at the closed ends of each unit will be filled in at the site with a 2-foot concrete closing strip to form a 6-foot wide corridor. Several finishing trades move in at once. First, the bathtub is located and connected to plumbing lines. Then the prefabricated bath area partitions, which also include dressing area and wardrobe storage, are erected, and water and electric lines are connected. The open end is then enclosed with a steel window wall and door unit. The frame is rubbed and painted, and the openings are glazed with bronze-tinted glass. Once enclosed, interior walls are smoothed up with a thin wipe-off coat of drywall joint cement, which covers any blemish and fills in pinholes. Using a wide paper mask to protect the wall surfaces below the inward sloping frieze trim area, the ceilings are sprayed with a textured paint, which, on drying, produces a strongly stippled surface which is both attractive and has desirable acoustic properties. Decorators then hang vinyl wall covering in selected color combinations, applying it directly to the prepared concrete walls. After carpeting is cut, laid, and tacked to edge strips, trucks of furniture and appliances, coated to match previously determined room decor, deliver beds, chairs, chests, lamps, pictures, and window drapes. All movable objects are affixed to walls or floors. This includes headboards and frames of beds, chests, desks, and tables. These precautions not only assure against future removal, but keep furniture and appliances from rattling around when they are lifted into place. The rooms were completed when the fascia and grill were applied to the air conditioning unit above the entrance hallway. This room unit, one of 20 to 25 delivered to the site each day, has everything in it for living except daily service items such as bed linen and covers, towels, bath mats, and washcloths. Truck trailers conveyed the units from the yard to the street in front of the structure. This was the only public area closed to traffic during construction. Units were attached to a special lift rig with 4 connectors and hoisted into place by a 100-ton crane. This crane, capable of a full 360-degree rotation, was able to lift all 496 units on both the street and the riverfront sides from 4 separate locations in the street. The units were placed in 2 long rows, both lines separated by the 6-foot corridor, which is served by the elevators in the service core. The rooms are stacked vertically, using alternate long and short units. They are also located alternately long and short horizontally to produce an attractive facade over which each of the 4.5-foot wide balconies is entirely private. To eliminate the need for tag lines to prevent spinning or swaying, Zachary's engineering staff fitted a helicopter tail rotor blade to the rear of the lifting frame. The pilot, riding the frame on its upward sweep, operated the controls which change speed and pitch of the rotor blade. This makes it possible to maneuver the unit for proper alignment over the room below. Despite wind and the normal pendulum-like sway of a heavy object at the end of a long cable, the pilot flies the room in. With the help of a supervisor in walkie-talkie contact with the crane operator, he can make a delicate 4-point landing. Prior to positioning each unit, accurate grades are taken by transit to determine location and proper thickness of 4 polyester grout leveling pads. The grout material is placed in a small steel form, leveled and dried by a heat lamp to produce 4,000 pounds per square inch in 30 minutes to 2 hours. Just before placing a room on the leveling pads, a 6-inch wide layer of cement sand grout is placed around the top perimeter of the lower room unit. Thus, each level of room units is in contact with and sits firmly on the leveling pads and grout bead of the rooms below. The room units are also connected by welding at both corridor and balcony ends. There is a 20-inch space between adjacent rooms, in which all utilities are stacked and connected with interior utilities cast in the walls or placed during finishing operations. These vertical openings are enclosed on the outer walls by precast panels with integral antique brick facing. The areas are accessible through removable closure panels in the corridor. Each floor is finished by casting a 2-inch thick deck in the corridor after filling the gaps between the cantilevered sections that form corridor ceilings. The methods developed for lifting and positioning made assembly of room units far more efficient than expected. Anticipated lifting of 10 units per day was increased to 22 to 25 during the latter phases of the work, putting pressure on the casting and finishing yard to keep up with building erection. On one day, 35 units went into place. All rooms were in place by December 21st, 1967, 32 working days after lifting started. While the last room units were lifted, lower rooms were finished by the simple daily procedure of making the beds and hanging towels in the ceramic tiled bathrooms. Although most of the rooms are separate units furnished with 2 beds, some were connected by casting door openings in adjacent walls. On the 20th floor, several room units were combined to form suites. This was accomplished by leaving larger openings in some room units and bridging the vertical spaces with special floor slabs. Feigenspan and Pinnell were structural engineers, and Schuchart and Associates were mechanical engineers for this unusual project. They, along with the Zachary Group and the architects, are convinced that this system is safer, easier, and more economical. Other owners, builders, and designers interested in systems construction will be eager to know the economies obtained through reduced construction time and minimum on-site fabrication, finishing, and furnishing.